Okay, thank you for the kind introduction, and thank you also for the opportunity to discuss our toolbox, Actigraphy, that we developed for the analysis of REST activity patterns. And I will try to see how you can link this toolbox with the NSRR MESA dataset. Thank you. So let's go, because we talked a lot about EEG and ECG. So I just wanted to flash quickly what Actigraphy is. Actigraphy is just a continuous measure of the activity levels. And actually, it is measured by most often wrist-worn devices that will integrate the magnitude of the acceleration over a certain amount of time, and give and try to quantify this as a number of counts. Most often the transformation is proprietary, so you have access to counts that are specific to your device, but nonetheless, at the end of the day, what you have access to is a time series that fluctuates with the locomotor activity of the participants. And there are multiple placement where you can wear the device. So there is a natural ambiguity that I felt I needed to quickly flash, is the fact that sometimes there is this kind of a conflict with like the sleep definition from polysomnography, and also sometimes you can see the term sleep used also in actigraphy analysis. And the ambiguity stems from the fact that if you are laying down without movements and still wide awake, this ambiguity of the locomotor activity will maybe let you score this period as sleep. So I would say that the activity is just a measure of locomotor activity from which you can infer wake and sleep. And ultimately, you should combine this signal to other kind of signals to have a kind of holistic view on sleep. So still, in itself, it has really a lot of value, this kind of a physiological signal. Okay. So now, concerning the rest activity patterns, this is a so-called double plot that shows the time series of the locomotor activity over spans of 48 hours that overlap for each row. And you see, like similarly to the ECG signal that was mentioned by Dr. Costa, the locomotor activity is a quite complex physiological signal that is regulated finally at different time scales beyond the obvious circadian modulation. So it is a quite complex signal, and there is a lot of information to extract from it. So it is worthwhile to develop tools to extract more information from just visual inspection of actigraphy data. And luckily, in the NSRR website, among the 26 data sets that you can browse through, actually there are 6 of them that contain actigraphy data, and one of them is the MESA dataset. That is, if I'm not mistaken, the largest one. That is also famous for containing concurrent PSG and actigraphy data. So this data set is actually a longitudinal study in a racially diverse cohort of roughly 7,000 participants. And what is brilliant is that there is a subset of those participants, roughly 2,000 participants, that had 7 days of wrist-worn actigraphy. And beyond, we have access to some summary variables. So the NSRR did a tremendous job to provide you summary statistics. So there are files that contains measures of that were extracted from the actigraphy measure, but you also have access to the raw data. So now imagine that you want to redo the analysis with different settings, or you want to pursue your own analysis with a specific variable at the end of the day. You need to have the appropriate tools to do that. And actually, we developed a tool for that. And that tool is named Actigraphy. It's a Python package that is hosted on GitHub. We developed the tool originally for our own need, but from the start, from the principle of the project, it was an open source. It was meant to be open source, and if it could be useful to the community, all the better. So it was released under the GPL3 license, There is a companion paper that has been published. And also what is most important, I think, for open source softwares, it content tests. It gives you confidence in the code, and it contains unit tests around 100 that are run each time we make modifications. And also to ease the use for newcomers, we have an extensive online documentation and tutorials also associated to that package. So now I will briefly flash what is the different, let's say, features of the package from the pre-processing. So you can actually read with the same interface various Actigraphy file formats. So there is like 8 of them. And one of them is the raw data format from the MESA dataset. So there are multiple tools also that allow you to do a manual, some steps that are extremely cumbersome, like the manual masking of the spurious inactivity periods. You can also visual sleep agendas if you want. You can also quickly compute average daily profiles. And also there are some tools also to process the signal itself, like signal filtering, smoothing, for expansion, Gaussian kernel smoothing, spline interpolation, if you want to go for functional data analysis, for instance. And also, since we are doing actually analysis with the tool, we also implemented various techniques for advanced signal analysis. So since we are a lab of chronobiology, we implemented the usual rest activity rhythm variables that you see here. We also implemented multiple automatic detection algorithms because there are several on the market, and then they have different properties. And then for historical reasons, you can identify different trends in the way they are implemented. And basically, if you want to compare them and see if your outcome also depends strongly on that one, you need to be able to quickly switch from one to the other. So we implemented some of them. There is also, we implemented the sleep fragmentation and the activity fragmentation via the state transition probability, which is a nice measure that has been linked to different outcomes, especially the progression of neurodegeneration, for instance. The modulation also, we can do some analysis around the modulation of the activity during the night. And actually, this is really an exciting analysis, that one, because it opens the opportunity to analyze at a large scale the sleep dynamics, the sleep cycle dynamics from locomotor activity point of view. And also we have advanced signal technique like the singular spectrum analysis that helps you to decompose the signal into additive components that you can maybe identify as the circadian and intradian components separately if you're interested in focusing on specific timescales. So all of this is implemented in our toolbox. And actually, we also, because it's we wanted to be useful to the entire community, so we developed a set of tutorials that quickly illustrate the different features that are available. And all these, along with the code, the tutorials are available online. They are also available within the package. Once you download the package from the Python manager website, you can also have access directly to the notebooks that are actually create that documentation and the tutorials. And we build those tutorials around notebooks, Jupyter notebooks, so that they can be run interactively and in a friendly environment, so that you can reproduce yourself the analysis and maybe build on top of those tutorials. And hopefully they cover the main functionalities that we developed. Now, just a quick slide maybe on how to contribute, if you want to, but contributing by using it, because we hope that it's useful for the community. It's meant to be a collaborative effort. So if you see issues or if you have features that you would like to see implemented, you can also report everything via GitHub. If you want to suggest improvements, because actually, you can't foresee all the use cases, but someone brings a new one and it opens new possibilities. So it's always nice to have suggestions, and you can also do it. Extend the doc, because the code is obviously quite clear to the developers, but maybe not so for the users. So if you identify corners where we need to expand the documentation, that is really important. Quickly, if you want to use it, please cite it. There is a convenient paper, and also it's hosted on Zenodo, so it has its own DOI. And just quickly, and to wrap up, because we were discussing the MESA datasets, and for which there is a connector to read the raw data files. I just wanted to show you that it's really simple to calculate, for instance, this REST activity rhythm variables, or if you want to just see the activity profile of a certain participants, for instance, the first one in the MESA dataset, you see like it's not more difficult than just these 4 lines. You import the package, you define the path to your data, and then you can just read the file. So this is the third cell, where you just say, look, with the read raw MESA function, you can say, look, I would like to read that file, and it creates an object. And that object you can use later on in the last cell, for instance, and say, look, please provide the computations for the intradaily stability, or the intradaily variability, or the interdaily stability. And this is not more than complicated than that. Now, if you want to look at the REST fragmentation, it's not more complicated. It's just 1 line. And if you want to inspect and see the profile, also, it's quite a few lines of code. So there is no graphical interface, but still, we try to lower the, let's say the threshold for which you need not much computational skills if you want to use the and everything actually is documented in a tutorial, so actually you can reuse them and apply them to your own analysis. So if I may just quickly conclude here, is that it is really brilliant that we have like large scale data sets that are now available for analysis. My only fear there is that you see, like, if you have a large amount of data, it means that the data processing itself, if you want to get access to the raw data, it might become an issue. We don't have all the computational or the coding skills to implement from scratch an analysis. So that's my opinion, that there is a need for a comprehensive open source softwares in our community, and we hope that we provided something that might be useful for the entire community, and it's meant to be a collaborative effort. So everybody is welcome to join and expand the functionalities of the tool. Okay, so thank you.
Thank you so much. That was really really exciting, and great to see how you're fully embracing sort of the open source community to help build your package. We have a couple of questions for Dr. Hammad. Can Actigraphy analyze light and skin temperature as well?
So from the skin temperature point of view, there are not that many devices that we support that have this signal. I can't think of one, but maybe I'm mistaken. But for the light, it's different, because there are plenty of devices that we support. And inside the MESA dataset, there is also the light signal. If there is the light signal, and I didn't have the time to cover that, but there is actually a spin-off project that was named PyLight that actually just got published. And this PyLight is really dedicated to the analysis of light. So if the device that is supported here also records light, you have a submodule that is fully dedicated to have a specific light variables on top of the variables that you already have access to through the main Actigraphy environment. So indeed, there is light. And indeed, that would be the more complex the device become, which is all the better, because you need to integrate all sorts of signals if you want to really apprehend sleep. That's why we would like to expand. So light was the first one. So maybe in the future, if we have the manpower and the funding, so it could be extended to many other sorts of signals.
And is that
for light? Yes.
That's including PPG?
That would be brilliant. That would be brilliant. But yes. But at the moment, it's mainly light that is supported.
I see. Okay, great. So we have another question that asks, if the Actigraphy instrument we are using is not one of the ones listed, is there a way to amend the program? Can we use data from other Actigraphy instruments or fitness sleep trackers?
Yes, as long as you have access to the raw data, Either you see like for instance, if you want to access like Activity provides you with the binary data, although the format is open, but actually there exists also software that will transform. You see, like there are specific software that will transform into a nice calibrated CSV file with where you aggregate the data every 30 seconds. And actually this kind of tabular format that you have access to, it's really easy to plug them. Actually in the tutorials, one of the last one is like, if I have a data frame, how do I plug that data frame? Because I read a CSV file, or do I plug it directly to Actigraphy? And then there is an example how to do it. And if you look at the different issues that were, you see like there have been requests from people, like among the file formats that we now support. Not all of them are from our lab. We started with the lab with the devices that we had at our disposal, but actually some of them actually were from requests from the outside, and we don't, for historical reason, we don't have this device, but still we implemented that because you see, like we sensed that there were a need from some groups to have it. So either we help you to do it, or sometimes people lack the skills. Sometimes we do it also for them. So it's really we try to collaborate. So if someone wants, then you can contact us.
Okay, one last question. So when you are building new methods into Actigraphy, for example, transition probability or LIDs, are you working with the actual groups to recreate the methods, or are you developing them independently just based off of the publications?
Most of the time we try to contact, because you see, like it's first because it's fair. So like people develop methods, they need to be aware that you develop method. If I forgot that, I'm sorry. But for the state transition, actually we're fortunate, like Andrew Lim was kind enough to share his code. It was MATLAB code, and then we could track the implementation that we did in Python and see if it matches. And also that's part of the game. You need to cross-check your code. Sometimes also the unit tests are really useful for that sometimes you can analytically calculate what should be the outcome for a certain signal, and that gives you confidence that what you develop is also correct. Most of the time we try to reach out for the groups. If a group wants a certain feature to be implemented, also they can reach out to us. So it's really a bi-directional work, I would say.